So, good morning students, let us start our class today. We are a bit late today, right? Now, as we discussed yesterday in our class that we are supposed to be discussing about Pythagoras theorem today. So, let us discuss about Pythagoras theorem as I told you yesterday also 6.4 exercise that is based on area theorem, which is not a part of your syllabus. The proof of area theorem, few questions we might discuss it later on when you come to school. Alright. So today we are going to discuss about Pythagoras theorem. Pythagoras theorem, we all know what is Pythagoras theorem, that is theorem number 6.8 of your textbook on page number 145. All of us know Pythagoras theorem. How do we read Pythagoras theorem, sir? Anyone we ask Pythagoras theorem, what is Pythagoras theorem, sir? Hypotenuse square equals to perpendicular square plus base square. But what is hypotenuse, what is perpendicular, what is base? Those all things we shall be discussing when we talk about trigonometry, right? But here we are going to discuss about Pythagoras theorem, and if you read the statement of the Pythagoras theorem on page 145 of your textbook, it clearly says in a right triangle the square of the hypotenuse is equal to the sum of the squares of the other two sides. Nowhere perpendicular and base is used. Why? We shall be discussing that in trigonometry, perpendicular and base. What is perpendicular and what is base? That all we shall be discussing. So here we can clearly see that nowhere he is saying that what is perpendicular and what is base. He is saying square of the hypotenuse is equal to the sum of the square of the other two sides. And we have to learn the proof of that. How do we prove Pythagoras theorem? So let us start proof of Pythagoras theorem. In a right triangle, the square of the hypotenuse, so I am drawing a right triangle. As it is given in your textbook, I am drawing the same way so that when you verify from your textbook, you can see that A, B, C, and this angle is 90 degree. So we all know which is the hypotenuse. The side opposite to 90 is known as the hypotenuse. Opposite to this angle B, AC is the hypotenuse. We all know that. But rest of the two sides, any of them can be perpendicular, any of them can be base. That is why the figure is drawn in such manner so that you don't get confused which is perpendicular and which is base. It says square of the hypotenuse, that is AC square, is equals to sum of the square of the other two sides. What we are given? We are given a right triangle ABC in which angle B is equals to 90 degree. What we have to prove? We have to prove that square of the hypotenuse AC square, because it is the side opposite to 90 degree, is equals to AB square plus BC square. This is what we need to prove. Construction, yes, there will be one construction, and then we come down to proof. Now we have just completed similarity in triangles. So that similarity in triangles we are going to use again in class in this proof. What construction we are going to do? We are going to drop a perpendicular from this vertex B, that is from 90 degree, on this side AC. See, this BD is perpendicular on the side AC. I am naming the same so that there is no confusion. BD is perpendicular on AC. Right? Clear? Now, one by one, we are going to prove the triangle similar. This is smaller one to the whole. This bigger one to the whole. That's it. Alright, similarity we had done exercise 6.3, question number 7 and 8. The same kind of similarity is going to be used over here. Check. In triangle ADB, in right triangle ADB and triangle ABC. Which one? ADB. This is smaller one, and A, B, C. this bigger one. Can you see angle A common? This angle A is part of this smaller one as well as the bigger one. So we can see angle A equals to angle A, that is common. And in smaller triangle ADB, this angle is 90, and in bigger triangle ABC, angle B is 90, angle D equals to angle B is equals to 90. So therefore, triangle ADB is similar to triangle ABC by what similarity? AA, angle. Two angles of a triangle are respectively equal, so two angles of a triangle are equal, so they are what kind of a triangle? They are equilateral, similar triangles. Now the most important part. If two triangles are similar, its corresponding sides are proportional. Now where are the corresponding sides? That is the most important part. We are talking about triangle ADB. This angle is 90, so opposite to 90, AD is the hypotenuse upon triangle ABC. This angle is 90, the opposite to 90, AC is the hypotenuse. So the hypotenuse are in the same ratio. Then triangle ADB, this angle A was common and this angle D was 90. So which is the side in between? AD. Upon what bigger triangle, this angle A was common, this angle B was 90, which is the side? AB, included side AB. And which is the third side of the smaller one? DB. Upon the third side of the bigger one? BC. Because triangles are similar, its corresponding sides are proportional. And now we are going to take the sides. Sir, why did you take these two sides? The question arises. Why did you take DB and BC? Check. DB was our construction. That was construction done from our side. DB is not a part of the triangle. So we have skipped the side DB and BC. Check. AB into AB. AB square is equals to AC into AD. AC into AD. Equation number first. We have cross multiplied. AB into AB and AC into AB. AB into AB square, AC into AB. Now, second triangle BDC and the bigger triangle. Now, in right triangle BDC and triangle ABC, where are these triangles? BDC, this is smaller one, and ABC, bigger one. Can you see angle C common in both of them? So angle C is equals to angle C, that is common. And then angle D of this smaller triangle is equals to angle B of the bigger triangle. Angle D is equals to angle B is equals to 90. So therefore triangle BDC is similar to triangle ABC by what similarity? AB. And if two triangles are similar, its corresponding sides are proportional. Search for the corresponding sides. Be very careful and search for the corresponding sides. Check opposite to this D. BC is the hypotenuse. So therefore BC upon hypotenuse of the bigger one AC. Right? Then angle C and this angle 90 is common in the smaller one. Which is the side included? CD. Upon this angle C was common and this angle 90 was for the bigger triangle. Which is the common side? BC. Is equals to which is the third side? BD upon AB. Again we take these two sides because BD is our objective. We have done the construction. So BC into BC, BC square is equals to AC into CD, equation number 7. Right? Check the two, AB square and BC square. Do we need the sum of these two? Add both of them. Adding equation first and second. Left hand side added to left hand side AB square plus BC square. AB square plus BC square is equals to right hand side added to right hand side AC into AB. AC into AB plus AC into CD. AC into CD. Check AC and AC. AC is common. What is left? AD plus CD. Check the figure. AD and CD. AD plus CD is equals to what? AC. So AD plus CD is equals to AC. AC into AC. AC into AC is what? AC square. Square of the hypotenuse is equal to the sum of the square of the other two sides in a right triangle. This is how we prove Pythagoras theorem. I hope it is clear. Very easy. That is why similarity is taught before, so that everywhere similarity is used. So here you can see similar triangles applied in both the triangles. Firstly, the smaller triangle was proved similar to the bigger one. Then this smaller triangle BDC was proved similar to bigger one. And when two triangles are similar, their corresponding sides are proportional. Clear? Now, 6.9 theorem, that is converse of BPT, is not a part, the proof is not a part of your syllabus, but it will be applied. It says, if in a triangle the square of one side is equal to the sum of the square of the other two sides, then the angle opposite the first side is 90 degree. He says if the square of one side is equal to the sum of the square of the other two sides, then the angle opposite to the first is 90 degree. That is converse of BP, nothing new. Now here the exercise is very easy. You have done these questions in class 6, 7, 8. The exercise is very easy. Alright, see the questions. Page number 150 and 151. Exercise 6.5. Question number 1. I don't need to solve it. Show that the triangles given below, sides of the triangles are given below. Determine which of them are right triangles. So definitely we know the properties of a right triangle. Hypotenuse is the longest side. So what we are going to do? We will check the longest side. Whether the longest side, the square of the longest side, is it equal to the sum of the square of the other two sides? Then it is a right triangle. If not, it is not a right triangle. For example, first question, 7 centimeter, 24 and 25. So we all know 7 square plus 24 square. 7 square is equals to 49 centimeter. 24 square is equals to 576 and 25 square is equals to 625. So we can see that 625 is equals to 576 plus 49. 625 is equals to 625. So they are the sides of a right angle triangle. If they are not equal, then it is not. For example, if I talk about 50, 80, 100. Square of 100, 10,000. 50, 2500, 80, 6400. So the sum of 2500 and 6400 is not 10,000. So they are not the sides of a right angle triangle. We all know 5, 12, 13 it is a Pythagoras triplet. 13 centimeter is equals to 12 square plus 5 square. It is a Pythagoras triplet, we call it. Clear? This is also Pythagoras triplet, 7, 24, 25. Because Pythagoras theorem is proved in these. Right? Now, question number second, third, you can try it out. They are easy. Question number 8, 10, 11, please check. Sorry, 9, 10, 11, please check. A ladder 10 meter long reaches a window 8 meters above the ground. These are the questions which you can do. I am not going to solve them completely, students. These are the questions you can do. I am giving you the hint. Question number 9. Exercise 6.5. Question number 9. A ladder 10 meter long reaches a window 8 meter above the ground. This is 8 meter. There is a window, say A, B, and the ladder. Ladder does not stand straight. It is always put it on slant. This is the ladder. Say C, 10 meter. He says, what is the distance? Find the distance of the foot of the ladder from the base of the wall. Which is the foot of the ladder? C. And which is the base of the wall? B. It is a right angle triangle. This is what we need to find. Yes or no? Can we do it? Which is the hypotenuse? So AC. 10 squared is equals to AB squared plus BC squared. 6, 8 and 10. They are Pythagoras theorem. Right? Second question, 10th question. A gay wire attached to a vertical pole of height 18 meter is 24 meter long and has a stake attached to the other end. This is a wire, this is a pole, 18 meter, and this is the wire 24 meter long. 24 meter long. And there is a stake, in Hindi we call it kuta, stake, so that the wire remains straight, and there is a stake which is nailed into the ground so that it does not move. Question says, how far from the base of the pole, which is the base Q, the stake, base of the pole, should the stake be driven so that the wire will be taut? Taut means straight. There is no curve into it, or there is no slope into it. Again, Pythagoras theorem, because it is a pole, it is supposed to be 90 degree. Right? Then, question number 12. This was question then in class 10, 8. Two poles of height 6 meter and 11 meter stand on a plain ground. This is a ground. One pole is of 6 meter, say AB. And another pole is of 11 meter, say PQ. Right? Then he says the distance between them is 12 meter. The distance between both these poles is 12 meter. If this distance is 12, will this distance be also 12? All of us know that distance between parallel lines is always equal. Now see, this is 6. So this will be, say I am making it R, this will also be how much? 6 meter. And total was 11 meter. So how much is this PR? 5 meter. Yes, question says, find the distance between their tops. Which are the tops of the two poles? A and B. So this distance he wants us to find. Is it a right angle triangle? Triangle PRA, which is the hypotenuse? PA. Square of the hypotenuse is equal to the sum of the square of the other two sides. 5, 12, 13 centimeters, 13 meters. I hope you can do all these questions. They are not difficult. They are straightforward application which you have done in lower classes. Right? They are not difficult questions. They can be done very easily. Same kind of question is question number 11. An aeroplane leaves an airport and flies due north at a speed of 1000 kilometers per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 kilometers per hour. How far will the two planes after 1.5 hours? Check. He's talking about direction. Question number 11. This is my direction table. This is how you can learn the directions. This is the direction. Mark. North, south. We all don't get, sometimes we get confused. So which way is east and west? So check over. Never eat sugar wheat. Clear? Never eat sugar wheat. Right? So now you can see which direction is east and which direction is west. The question says, read it carefully. A ladder 10 meter long. An aeroplane leaves an airport and flies due north at a speed of 1000 kilometers per hour. Say this is the airport at O, and an aeroplane is going in this direction, no other direction, at what speed? 1000 kilometers per hour, and reaches this point A. Then he says another aeroplane leaves the same airport and flies due west and reaches over here, say C or B, And what is the speed of this aeroplane? 1200 kilometers per hour. The speed of the two aeroplanes is given to us. Question says, how far apart will they be in 1.5 hours? How far they will be in 1.5 hours? So see, speed is given to us, time is given to us, 1.5 hours. Time is given to us. Can we find the distance? Same over here. Speed is given to us. Time is given to us. They are traveling for 1.5 hours. And can we find the distance? We will get this distance OB and OE. They will be the distance. So we know the formula for distance. Speed is equals to distance upon time. So speed into time is equals to distance. What is the speed? 1000 kilometers per hour into speed 1.5. 1 2s are 2 and 1, 3 by 2 hours. 2 1s are 2 5s are 5 3s are 1500 kilometers. How much is this distance OA? 1500 kilometers. 1500 kilometers. Same way, this distance, speed is equals to distance into time. So 1200 into 3 by 2 is equals to distance. 2 1s are 2 6s are 6 3s are 1800 is the distance. 1800 kilometers. So this distance is how much? 1800 kilometers. OB. So it is a right angle triangle. Can we find the hypotenuse AB? How much is this distance? 1500. How much is this distance? 1800. The only thing, we have to get a relation between speed and time. Clear, students? So these are the questions that you can very easily do. Question number 9, 10, 11 and 12. Few more questions are there which are straightforward questions, only application. I am removing these. You may have copied it, you might be able to solve it. Please check. Question number, I am removing this part also. Question number 4th and 5th. We will do it parallel. Question number 4 and question number 5. We will do it together. What does it say in question number 4? ABC is an isosceles triangle right angled at C. ABC is an isosceles triangle right angled at C. C is 90 degree and this is an isosceles triangle A and B. This side is equal to this side. Definitely, hypotenuse cannot be equal to any of the sides. Hypotenuse is the longest side. So it cannot be equal to any of them. So what is given to us over here? We are given right isosceles triangle ACB in which angle C is equals to 90 degree. What we have to prove? We have to prove that AB square is equals to twice of AC square. AB square is equals to twice of AC square. Let us come down to question number 5. What does it say? ABC is an isosceles triangle with AC equals to BC. It is an isosceles triangle with AC equals to BC. ACB, AC is equals to BC. Given isosceles triangle ACB in which AC is equals to BC and AB square is equals to twice of AC square. And what we have to prove? We have to prove that it is a right triangle. Yes or no? He says prove that ABC is a right triangle. To prove that triangle ABC is a right triangle. Can you see? Both these questions are converse of each other. Here he is telling you that it is a right angle triangle. Here we have to prove AB square is twice of AC square. Here it is given that AB square is twice of AC square. We have to prove that it is a right angle triangle. They are both converse of each other. Isn't it? So first and the foremost thing, which of them is a right triangle? So this is a right triangle. Can we apply Pythagoras theorem? Definitely, sir. Since it is a right angle triangle, we can apply Pythagoras theorem. All of us know that proof. In right triangle sum of the square of the other two sides. So which is the hypotenuse? AB square is equals to AC square plus BC square. Yes or no? Square of the hypotenuse is equals to sum of the square of the other two sides. Right? This is what we have written. And we want AC square twice of AC square. Can we replace this BC? AB square is equals to AC square plus, in place of BC we are writing AC square. So why? Because AC is equals to BC given to us in the question. It is an isosceles triangle. So BC is changed to AC. AC square plus AC square, twice of AC square is equals to AB square. Hence, simple. This question might be asked in 2 marks. Might be, not necessarily. Converse of this is over here. Converse of this, exactly converse. Is it a right triangle? No. Can we apply Pythagoras theorem? No. It is not a right triangle, so we cannot apply Pythagoras theorem. Then what can we apply? We can start from whatever is given to us. AB square is equals to twice of AC square given to us in the question. See? Same. Now we are going to reverse. Twice of AC square, can it be written as AC square plus AC square? Definitely, sir. But AC is equals to what? BC. So AC square plus this AC is converted into BC. Write down the reason, because AC is equals to BC given to us. Now what do I get? Observe it. Now what do I get? AB square, that is the side of square of one side, is equals to sum of the square of the other two sides. So please check theorem 6.9, the statement. It says if square of one side is equal to the sum of the square of the other two sides, then the side angle opposite to the first side is 90 degrees. Here now, by converse of Pythagoras theorem. Which theorem that is? Theorem number 6.9. The angle opposite to the first side is 90 degree. Therefore, angle C is equals to 90 degree. So therefore, triangle ABC is a right triangle. First was application of Pythagoras theorem. Second was application of converse of Pythagoras theorem, which we did not prove, but we have applied, we have studied it. Both these questions are related to each other. You can see in this it was a right angle triangle, so we applied Pythagoras theorem. Here it was not a right angle triangle, so we did not apply Pythagoras theorem. Clear? So these are the kind of questions that are asked in the exam. Sixth question. Sixth question also you can see. ABC is an equilateral triangle of side 2A. Let us draw. Let us see what is he meaning. He says equilateral triangle of side 2A. Okay. Question number 6. This is an equilateral triangle. A, B, C. Equilateral triangle means all sides are equal, 2A, 2A and 2A. Right? Then he says, find each of its altitudes. We know that altitude of an equilateral triangle are all equal. So we are dropping one altitude over here. Say D, this complete side is 2A. And this is B. Given what is given? Equilateral triangle ABC, in which side is equal to 2A. What we have to find or what we have to prove? Length of altitude. Length of altitude, that is AD is equals to how much? This is what we need to prove. Construction? No construction required. Proof. Can you see this is a right angle triangle? Both of them? Definitely. And can we find out? We know that the perpendicular, the altitude of an equilateral triangle bisects the side. We know What do we know? Perpendicular of an equilateral triangle bisects the opposite side. Therefore, BD is equals to CD is equals to half of BC. BD is equals to CD is equals to half of BC. And we all know all sides are equal. So half of BC is how much? 2A. 2 and 2 cancel. So that is A. So therefore, BD is equals to CD is equals to A. Right? It is A. Now can we apply Pythagoras? Now in right triangle ADB by Pythagoras theorem. What is Pythagoras theorem? Square of the hypotenuse AB square is equals to AD square plus BD square is equals to AD square plus BD square. How much is AB? 2A whole square. AD we have to find. BD is A. 2A square is 4A square. A square comes over here. Minus A square is equals to AD square. 4A square minus A square. 3A square is equals to AD square. Square goes on the other side. It converts into root. And root of 3 is root 3. Root of A square is A is equals to AD. So this is the formula for the for the altitude of an equilateral triangle. So these are few questions that easily you can do. Question number 1, 2, 3, 4, 5, 6. We have discussed question number 9, 10, 11, 12. We have discussed. These are the kind of questions. In the next class, we shall discuss the rest of the questions.